In this video tutorial, we will be creating parts, assemble those parts, and create drawings of some of those parts. So let us start by creating a new part file. So let us change the system units. Go to the system options, then document properties. Under drafting standard, let us change this one to ANSI. And under units, let us select IPS and change the number of decimal places to 3. Then OK. It is good to keep in mind that if you are creating parts for an assembly, make sure that all the units are consistent. Okay, so if I'm going to use IPS, so all throughout this video tutorial, we will be using the inch pound second system of units. So let us sketch. Select the sketch command manager tab and then select the sketch tool. Then the 3 major planes or default planes of SolidWorks will appear. Now let us select the top plane. Select the center rectangle, and you need to start at the origin. After creating or drawing a rectangle entity, you need to dimension that profile. So let us give this dimension as 3.5 inches, then OK. And then this one will be 3.5 inches also. Now I'll just go to the Features Command Manager tab, select Extruded Boss Base. So this will be the base part of the grinder assembly. So under the direction of the Boss Extrude Property Manager, it should be blind, upward direction. So I'll just provide a depth of 0.75 inch. Then OK. Now I will be creating cut profile on this face. So I'll just select this face, or simply you could select sketch tool, then select the face of this side or the front face of your face part. So I'll just click this one, then I'll just change the orientation view to front view. So I'll just draw the profile now. So I'll just use the center line, connect to the origin midpoint, and then midpoint at the top. You can press the escape key or simply right click and then select. So I'll just use the line. I'll just sketch a horizontal line along this edge, an angled line, and another horizontal line that connects to the center line. Then I'll just right click and then select. Now I will be mirroring these entities to draw my sketch profile. So mirror entities. Under the mirror property manager, entities to mirror, select the solid lines. Then make sure you place a tick mark on the copy and mirror about. Let us select the center line. Then OK. Now let us add some dimensions. Say the height of this profile. Say it should be 0.375. Then OK. Then provide an angle here. Select this line and this one. And let's try 76 degrees. Then OK. Now the length of this one will be 0.5 inch. Then OK. So this will be my profile now. Then proceed to Features, Command Manager tab, and select Extruded Cut. Then I'll just rotate the model so that I could view the possible output of that extruded cut. So under blind condition, I'll just change this to true all, and I'll just select OK. Similar procedure, I will be sketching the same profile here, then provide a cut all throughout this face. So I'll just sketch, select this face, then I'll just change my orientation view. I will select normal 2, then similar profile will be sketched here. Then dimension it. Then this is 0.375, and you have an angle of 76. Then let us mirror these entities. Mirror about the center line, and OK. Then provide the last dimension, which is 0.5, and OK. Then again, go to Features tab or Command Manager tab and select Extruded Cut. That is true all. Then OK. So I'll just change to isometric view, and this completes the base part of the grinder assembly. So I'll just save it. I just create a folder, SolidWorks Overview, then change the name to base, then save. So next, I will be creating the next part, which is called the slider. So just close this one. Next, I will be creating the second part, which is called the slider. Similarly, I'll just create a new part file, then OK. Make sure to change the units similar as before. Then 3 decimal places, then OK. Then I'll just select the front plane, then select sketch, then I'll just draw vertical center line, then additional lines. Then I'll just use mirror entities, then I'll just select those solid lines under entities to mirror, and then mirror about, then I'll just select the center line, then OK. Now I'll just dimension them using smart dimension. Then this will be 0.75. Similarly, this is angled 76 degrees. Probably this is 0.2, and this one, say 0.4, and also this one is 0.5. Then OK. Then under Features Command Manager tab, I'll just use Extruded Boss Base. Then under the condition blind, I'll just change that to mid plane and provide a thickness of 1.25 inches. Then OK. Then I'll just select the top face, then sketch. Then I'll just change my orientation view, which is normal 2 or Control 8. I'll just draw a circle at the center. Then the diameter of this one will be dimensioned using smart dimension. So this is 0.125 inch. Then I'll just go back to features, extruded cut, rotate the model, so change that to blind, and then the depth will be 0.5 inch. Okay, and then okay. So I'll just change it to isometric view so that I could have a preview of the model. Then this completes the slider part. So again, I'll just save that part, same location as where I saved my base part. So I'll just change this name to slider and then save. So I'll just close this one to create the third part of the assembly. So again, create a new part file, change your document settings to IPS and 3 decimal places, then okay. The third part that we're going to create is called the knob. Okay, so I'll just sketch in the front plane. I'll just use line. I'll just draw this profile here. So I'll just create a tangent arc. Okay, so I'm in the line mode. Okay, so I'll just hover my cursor to the last endpoint and then draw an arc. And then similarly, I'll just draw tangent arc here, then line and another line, then okay. Then I'll just dimension this one as 1 inch. Then this will be 0.125. Then this one is 0.375. Then okay. And this one probably has a radius of 0.25. Then this one is fully defined. Okay, then I'll just go to features command manager tab and I'll just select revolve boss base. So axis of revolution will be the this line, angle. Okay, you could preview the output 360 degrees, 1 revolution. You could decrease that if you want to, so that you could see how revolve features act. Okay, so that is under 301 degree. Okay, you could reverse the direction and so on. So I'll just provide 360 degrees here and then okay. Now I'll just rotate the model to see the bottom face. So for that bottom face, I will sketch, select that bottom face, then I'll just change to normal view, then I'll just draw a circle here to create an extruded cut feature. So the dimension or the diameter of this circle will be 0.20, then okay. Then extruded cut using the features here. Then the depth of that cut will be 0.5, then okay. So this completes the knob. So I'll just save this part as the knob and save. So I'll just close this part. Then I'll just create the last part, which is called the handle. So similarly, I'll just create a new document part and then okay. And then I'll just select the top plane. But before that, I almost forgot, we need to change the units. So I'll just go to the document properties, drafting should be ANSI, and then units IPS 3 decimal places. Then OK. Let's select the top plane and then sketch. I'll just use corner rectangle. So orientation should be top. And then I'll just draw center line connecting the midpoints of those sides. Then draw some circles here. Then provide dimensions. Let's say this is 4 inches. And this will be 0.75. Then the diameter of this circle, let's say this is 0.20. This is, let's say, 0.125. Then I'll just add relation. I'll just select the two circles. This is one of the how you add relations to two entities. Then they should be equal. Then OK. Then the distances between those two centers, say this is 1.5. Then the distance of the center of that circle to that edge, let's say this is 0.5, and this one 0.5. Then OK. Now the sketch is fully defined, so I'll just select features, extruded boss base. Then the thickness of this handle, let's change that to 0.125. Then OK. So I think that completes the parts. So I'll just save this file as the handle. I just close this one. Let's try to open the base. Then I'll just select file and make an assembly from this part. So from this moment, we will be creating the assembly file for the grinder assembly. Okay, so I'll just select file, then make assembly from part. Then a new document file will be invoked. This will be the assembly environment of SolidWorks. Notice here, begin assembly. Okay, this is similar when you insert components. Okay, since the open documents is base part. Okay, so I'll just click OK so that their origin will be coincident to each other. So the origin of the base part and the origin of this assembly file will be coincident, and that base part will be fixed to this graphics area. And meaning to say, when it is a fixed component, therefore it doesn't move or it cannot be moved. Okay, so inserting of components, you can use the assembly command manager. Then insert components, drop down, then insert components. Then you could select browse, then you could select the nav, then open. Then if it's attached to your cursor, you can place it anywhere in the graphics area. Another way of inserting components is you open the folder where you have saved the files. Then you could simply click, hold, drag, then release. And we need two sliders, so I'll just drag them here, and one handle. Then I'll just close this or minimize this folder location. Upon assembling, okay, so we will be using the mate tool under the assembly command manager. So first things first is that we need to mate those sliders, okay, on this sliding path of the base. So I'll just select mate, or before that, if you want to move those components, you cannot, sometimes you cannot click drag them. You could use the move component, then you could click hold those components, place them where you want. Okay, so I just escape the move component. Later on, we will be giving you additional tutorial videos about some other tools available in the assembly file. Okay, so let us mate. Okay, so under the mate selections, you can select faces, okay, or edges, or even vertices. So let's try to mate the face of the one of the slider. I just select this face, and then the other face of the sliding path. So let's say this face. Then SolidWorks provide you automatic relations for that mate. It selects coincident, so that's great. So I'll just select coincident, then I'll just press OK. Now let us mate again. Okay, so the bottom face of that slider and the top face of the sliding path, let's say this one, then that's coincident. I'll just select OK, then I just cancel this one or select OK. Okay, so to view my output, let's see if it would slide here using the move component. So it slides along that path. Okay, so if I'm going to move my cursor up or down, it simply slides through this path. Okay, because those faces are coincident to each other. Now similar mate applied to this second slider. Okay, so I just select mate, select that face, probably this one. Okay, so if this orientation isn't similar to your orientation, you can select mate alignment, okay, aligned, or the other way around. Okay, and then I'll just select coincident, then okay. Then the bottom face and the sliding path, coincident, and then okay. Then I'll just move that component, this portion, to check if it slides along that path. So it's great. Now I'll just mate those holes together with this one. Mate, you could select edges or the faces, so I will be selecting the faces. Let's try this one. Should be concentric, it's great, and then I'll just select OK. Then similar procedures applied to the other hole together with this one, concentric, then OK. Then I'll just cancel this one. See, you can move this handle upward so that you could select the bottom face of that handle. So I just select mate again, bottom face, and then the top face of one of those sliders should be coincident. Okay, then let's see. So let's try to move that component so slide smoothly. Okay, so I'll just mate this knob, so the bottom face and the top face of the handle, it should be coincident, and the holes should be concentric. So let's try to select those holes, faces of those holes, concentric, then OK. So if you're having hard time selecting faces, you could select move. You can move some of them, then select mate, then the bottom face and the top face of the slider, then OK. So I just select Okay, and then try to move that component. So there is still one more missing mate command, so I just mate, and then let's try to mate selecting the knob here. I just select the front plane, then the handle. What plane? I could simply select this one, this side here. They should be parallel. Then okay. Then okay. So again, let's try to move that component. So it moves along the cursor now. Okay. So there are some missing components here, like screws. Okay. So let's try to use the toolbox here. Under the task pane, design library, toolbox. Okay, so select add in now. Now let us select some of those, let's say unsymmetric, and let's try bolt screws. Now let's try machine screws. Okay, so let us try to use pan crosshead, this one. I just click, hold, and then drag. So I'll just change this to, let's say, M3. Then length, let's try to 5. Then okay. Then I'll just select OK here. Then I'll just place them inside those holes, or you could simply click here in the graphics area. So I'll just click here, add some mates. Then I need 2 for these 2 holes here, and I'll just cancel this one. Now I'll just use mate. Then these holes. Okay, so it should be called concentric. Okay, so there it goes. So I'll just move that component. Then I'll just mate. Make sure this face here is selected, and also the top face of the handle. Then okay. Similar procedure is applied to these holes and this screw here. Then concentric, then okay. Select the top face and then the bottom face. Coincident, then okay. So again, I'll just insert another pan crosshead. Oops. Meet tool is still active, so I'll just cancel this one. So I'll just click, hold, drag, release, and then I'll just change this to M5, and the length probably will be 8 to increase some of those length. Okay, then okay. Then I'll just cancel because I only need 1 for this bottom hole here. So I just mate, select this face and then the face inside that hole. Notice their alignment, so I'll just change the alignment to align. Okay, and then that is concentric, and okay. Then I'll just select this face and the bottom face of the handle. Should be coincident, then okay. That completes the parts of this slider assembly. So I'll just select the isometric view, and then I'll just move the component here. Okay, so it rotates smoothly together along with the cursor. Now I just save this file together with the parts. Okay, so upon this warning, would you like to rebuild the document before saving? Okay, so rebuild and save. This is the recommended. then save the file as grinder assembly. Make sure they are located together with the parts of this assembly. Okay, so save. Then let us close this one, and the base part is still open. And then let's try to create some drawings. Okay, so let's try to create a drawing from this part. So make drawing from part, selecting file, make drawing from part. Okay, so sheet format size, let us try CNC landscape, then okay. So this is the view palette. So before selecting those views, I just click in the drawing sheet, then right click sheet 1 and then properties. Okay, so the scale is 1:1. Okay, so I'll just change this to 2:1. Third angle projection for the ANSI, and then apply changes. Okay. So notice here the drawing number states the base. So this is the file name of that part, which is the base. You could edit those portion by simply right clicking here, edit sheet format, and you can double click this one, then you could change that to drawing number, let's say 01, and then I'll just delete this one here, or edit text probably. Let's try base for the title, base part. Okay, then you could highlight them all, change the font size. You can also change their formats. Okay, and just leave it that way. Then I'll just close this one, then okay, and then I'll just exit this edit sheet format. Okay, so now inserting those views. Okay, let's say view palette under the task pane. Okay, so I'll just refresh this one, then I'll just select, let's say, the front view. Okay, so I'll just click, hold, and then drag, then release. Then moving your mouse cursor upward, that gives us the projected view of this given front view, which is the top view. Also on this diagonally, that gives us the isometric view. So I'll just click this one, and probably we do not need the right view. Okay, so I'll just select OK. And by the way, you could change those display styles here, and also the scale if you wanted to change them. Okay, so I'll just click OK. So I have the front view, then the projected top view, and then this is the isometric view. Change it here. Now I'll just provide some dimensions. I could use model items or simply use this smart dimension. Let's try model items. Then selected feature, entire model. Let's try entire model. Then I'll just click OK. Okay, so those are the automatic dimensions. But then here, as you notice here, 19.05, 12.70, 76, 9.53, probably my units didn't change. Okay, so I just change them using the system options, document properties. Let's try and see. Under units, I'll just change to IPS, 3 decimal places, and then OK. This one should be in IPS, so that is in IPS, so there it goes. So these are the measurements earlier when we created those parts. then this one 0.5, so I'll just simply delete this one. Okay, so delete on the keyboard. Okay, so let us try to save this file. Save as similar to base, but then the file type is SolidWorks drawing, which is SLDDRW. The part file has a file extension of SLDPRT. Save it to the similar folder. Okay, so remember these values here. Okay, so I'll just close this one. Now let's try to analyze how they are fully associative to each other. So let's try to change the appearance of this part. Okay, so I just right click. Okay, then appearances, say the base, the whole part. So I'll just select some colors here. Let's try this one. Okay, so you could select different colors if you wanted to. Okay, this is just an example on how you would see that they are fully associative together, the parts, the assembly, and also the drawing itself. So I'll just select that color and then press the OK key here and then save the part. Then let us just close this one. Go to the folder. Okay, you have your drawing part file here. Let us just open this one. Okay, so I'll just click this one and then change that to the display style to shaded with edges. Okay, so I just save this one, close, and then let us try to open the assembly file. This one. Then rebuild this document. Okay, so rebuild. See here, the appearance of the base part changes. So likewise, if I'm under the assembly file, okay, so I just change this appearance here, right click. Okay, then I just change appearance to the whole part, which is the knob. Then change the color here. So let's try this one. Then okay, then I just rebuild this one. Then let me just open the part file of that knob. Okay, so the appearance on the part file also changes. So let me just close this one. Yes. Okay, so similarly, if you're going to change the appearance of this one, let's try the handle. Then okay. Then similarly, if you're going to open that handle, okay, so the appearance also changes. I just save yes. Okay, now let us go back to the drawing file. So in this drawing file, I would change the dimension, probably this one. I'll just double click that one and I'll just provide 4, and also this one as 4. Then I'll just rebuild. Then I'll just close this one, then save all. Then I'll just select yes, so that it will rebuild the assembly file. How are we going to know if the length or width of this base part changes? Let us open the part file or the base part here. Okay, so I'll just go back to the sketch of the base part. Notice here it changes also to 4 inches and 4 inches. So the part, the assembly file, and the drawing files are fully associated to each other.